Hey there! Welcome to another episode of Raw Green, a show produced by Obi, a sustainability consultancy specialized in life cycle assessment, research, and green techs. Learn more about us on oneobi.com or take a look at our pages on various social medias. Links are ready for you in the description. Ciiiao! I am Francesco Lieto. I am passionate about sustainability and green technologies. Welcome back to a new episode of Raw Green. Whether you work in clean tech or not, or more specifically in clean energy generation, chances are you've heard this magic little word, grid. The grid is the electricity highway that allows energy produced in remote parts of the country, or even in entirely different countries, to reach your home sockets. So, what's the matter with the grid? What are the issues? Today, we have the pleasure of welcoming to Raw Green Dr. Jason Huang. Dr. Jason is someone who knows a thing or two about the grid. His company, TS Conductor, has developed a solution that can help unclog the grid and accelerate the deployment of clean energy. The solution is so effective and has so much potential that it has attracted the interest of major investors, including Wellington Management, Bill Gates' very own Breakthrough Energy Ventures, and Edison International, just to name a few. Dr. Jason, welcome to Raw Green. How are you?
Thank you very much, Francisco. It's a pleasure to be here with you today.
Oh, I'm so happy to have you here. I wanted to do an episode about the grid for such a long time because the grid, it is at the center of everything that clean technologies, especially clean energies, are trying to achieve. Okay, it is right now, it is the bottleneck, but it shouldn't be that way. So I really want to capture your expertise on everything around the grid. So get ready today. I'm going to grill you. Okay. I really want to know everything about the grid. And I would like to start, if you don't mind, with a brief intro of how the grid it is composed and how it is evolved. And what do you think it is going to be the grid in 5-10 years?
That's a very good question. When you think about the grid, you should think about electricity that is provided with reliability, with resiliency, with safety that keeps our lights on at all times. It is connecting all the generations. It could be, let's say, the traditional power generation as well as the renewable generation. And also, it is connecting to the load centers such as hospitals, factories, cities, as well as what we're becoming familiar, data centers, AI-driven load growth like data center. And the grid is considered to be the most sophisticated and largest machine on Earth. Keep that in mind. This is one of the, I would say, biggest, most important inventions of all times. And even though the grid is the largest machine on Earth, it's not quite large enough to take in all the renewable generations that we have today. And we have to wait for years to get those renewables to connect to the grid because it's a bottleneck. It also does not have the capacity to handle the two-thirds energy that we consume today that is not in the form of electricity. And you could simply put the simple phrase in place that without grid, without transmission, there is no transition.
Transition, yes. I love that one. I love that one. It's true. And when you frame it that way, that there are the 2/3 of energy that we are currently use that are not in the form of electricity, but that a very big portion of those we are trying to move towards electricity. that gives you just a little idea of the staggering challenge that there is in front. So what I wanted to ask you, it is a little bit more technical, okay? So you on the grid, you have three major components, which is the generation, the transmission, and the distribution. And the generation part, you tackle it. You said it. It is changing. There is a queue of renewables that waiting to be connected to the grid, and that obviously changes the management of the following two parts. So the transmission and distributions. Can we go a little bit more granular on the transmission and distribution part?
Yes. To minimize the loss in the transmission of electron from where it's generated to where it is consumed, we normally deploy very high voltage transmission lines. And then those transmission lines at high voltage need to be connected to the lower voltage, which is a distribution that reaches, for example, the factories, the cities, for example. So when we generally speak about grid, it is about transmission and a distribution. And obviously, load and generation, they're important. So you have the generation being the power plants, right? And then the consumption of the electricity, these are the cities, the hospitals, the factories, and they are all related to the grid, but the essential part in the grid are the transmission and distribution power lines and the substations that we work with.
Okay, wonderful. And that's where also TS conductors kicks in. So can you tell me, please, what TS conductor does and what problems solves?
Yeah. To answer that, I probably need to elaborate a bit more in terms of what is the real bottleneck in the power grid.
Please.
The wires, the wires that are carrying electron in our power grid is the real bottleneck. Those wires are based on century-old technology invented in 1908. They have a capacity constraint. And the reason for that is because when those wire technology were invented in, more than 100 years ago, we were relying on century ago, the steel wire wasn't strong enough. So we were using steel at the time that needed the strength contribution from hard aluminum. Just to be a little bit more technical here, the hard aluminum cannot handle high temperature, and this is what limits capacity. And unfortunately, the technology that was invented in 1908, it is called ACSR. It is still the dominant form of conductors in our power grid. And when you are unable to carry as much electron as you wanted, you have that bottleneck, and that people refer to bottleneck in our power grid. That is what it is, that the wire itself is incapable of carrying the necessary electron to facilitate energy transition. So move forward in terms of technology evolution in conductor space. In the 1970s, we had better steel, which is stronger steel from our steel industry. And we then were able to combine these stronger steel with so-called annealed aluminum, which gives you the ability to operate at high temperature for high capacity. The problem is the steel wire, they expand when hot, which creates excessive thermal sagging issue. And that excessive sag is what's handicapping the technology that we call ACSS conductor. To address the issue related to excessive sagging, unlike the steel in the traditional conductor, like the ACSS or ACSR, composite core material was used that has lower thermal expansion, such as ceramic fiber composite or glass and the carbon fiber composite, to replace steel in the conductors. So now you have a conductor that is capable of going to high temperature for high capacity and with the thermal sagging managed. Unfortunately, our industry experience with these first generation advanced conductor has not been positive. They're
Why?
known to be delicate.
Okay, they're delicate.
They're known to be delicate, difficult to work with, easy to break, and longevity concerns as well. And they are also very expensive, used for niche applications at best.
Yeah.
And this is why TS technology was developed. It was developed and started to see commercialization in 2016. This technology solved all the problems associated with the first generation advanced conductor at its source. It designed in safety, reliability, longevity, and easy installation, easy maintenance from the start by using what we call effective protection for the pretension carbon core, using a continuous, seamless, relatively thick layer of aluminum sleeve that is also fully conductive. And this technology shifted three paradigms in conductor technology. One is now you can go to high temperature without the sagging issue because the carbon core has virtually no thermal expansion. You can also maximize the amount of aluminum for optimal ampacity, which is also the capacity, without conductor weight penalty. Why? Because the carbon core can eliminate about 80% of the weight associated with steel. And lastly, it is also able to leverage the most conductive aluminum, the annealed aluminum, without compromising on conductor strength. Why? Because the carbon composite core in TS is twice the strength of steel. So you actually end up with a stronger conductor. And by the way, the utility also care about reliability, resiliency, as well as safety. This product, this technology, is designed to be corrosion proof because of that aluminum encapsulation protection that protects the carbon composite core. And the sag-free temperature tolerant feature allows this conductor to do a lot better when you have a wildfire situation because it will provide that sufficient clearance from, let's say, a ground fire right below the power line versus the traditional conductor that's going to draw them closer to the fire because of sag. And it could be hot enough to melt those wires. If they survive, their aluminum would have been changed to annealed, and that will create permanent sagging problems. And it's also, this technology of TS is a compact, strong design. It allows it to handle extreme wind from hurricane and ice storms a lot better than the traditional conductors. So it is a technology that addresses all the concerns associated with the prior generation advanced conductor. So we called it next generation advanced conductor.
Well, it is a lot. It does a lot. If I wanted to be on the problem solving capabilities of this, okay, I've heard of connection times to the grid for large utility scale renewable energy power projects that can reach 3 to 5 years waiting time to reach that. If from tomorrow every single grid operator and utility in the US decides to switch and start to use TS conductor, how long will it take to, let's say, reach connection times that could be decent? Let's say 6 months connection time, 3 months, 6 months connection times. How long will it take? How many kilometers of lines you have to install?
Yeah. First off, to connect the renewable generation, you have to have the grid with sufficient capacity. And the quickest, fastest way to upgrade our grid capacity is using technologies like TS. Because with the same structure, without any structural retrofit, such as getting the towers taller, or strengthen the cross arm. We don't need to do any of that with TS technology. You could actually double or even triple the transmission capacity with TS conductor in reconductoring. And what does that do? Imagine if you have 3 times capacity in our grid today, we will be able to connect all these renewable generations instantly. That you will not have the grid congestion problem that is handicapping the grid connection wait times for all the renewable generations. And I would also venture to say that it will also allow electrification of everything with speed and also with affordability. Now you can connect with, for example, all the EVs, the data centers, the industrial process, the heat pumps, without having the concern about grid congestion or reliability issues.
That is a lot. Already data centers, they are.
Yeah, Francisco, let me give you an example because this is important.
Please.
We have a customer called Montana Dakota Utility, March 2021. They had a 230 kV line. They needed to upgrade the capacity of that line so that they can connect and facilitate several wind farms in their service territory. And they were initially using the traditional conductor technology called ACSS, and they were able to get the capacity up to what they need, but they had to retrofit 90% of the structures. And for the 11-mile segment of that transmission project, they switched to TS conductor. We were able to save them 40% in total project capex because we avoided all the structural retrofit. And when the project was done, we were able to allow the project to be finished 12 months ahead of schedule. We got it done in 3 months versus 15 months with $1.8 million capex savings.
Okay, that is a good example, Doc. That is a good example. Wow. Okay, so that. I mean, what I cannot understand it is why it is taking so long. Why it is taking so long? Why are you waiting? Why utilities are waiting to implement technologies like that? I mean, I've seen when I first heard about TS Conductor, and that would give me, okay, these guys, they have the numbers on the top of their fingers. It is that you also offer, you also provide the ESCO service, the energy saving service. So you work in partnership, both providing technology and finance to the utilities generator. So that means that there is a very high level of data knowledge over there, of technology knowledge, of bankability of the technology. So how are you seeing the demand growing? Also, I've seen that you recently closed a fundraise in summer 2024, in this summer, the previous summer, to open a second facility. So if you can please give me a little bit more insight on how TS Conductor it is doing.
Yeah. First off, I have to say that we have been very blessed with industry support. We've also been recognized for several awards. We won the Edison Pioneers Innovation of the Year Award from Public Utility Fortnightly last year. We also won the Platts Global Energy Award last year, as well as the DOE's Cable Prize competition. And this year, we were named by Bloomberg as one of the Pioneer Award recipients. We have grown at, I would say, warp speed in a very conservative industry. And we have enjoyed also support from visionary utilities. You mentioned about Edison International, but we also have support, financial investment from National Grid, NextEra, Quanta Services, as well as, you mentioned about Breakthrough Energy Venture, Wellington, Blue Earth, as well as EEI. And Bill Gates has its own investment venture called Gates Ventures. They also separately invested in us.
Wow.
I do want to make a comment, Francisco, about why our industry has been slow in adopting technologies like TS, or pretty much for all the other technologies. One of them that's unique to conductor technology is the industry had a very bad experience with the first generation advanced conductor. And they, without knowing TS being fundamentally different, engineered to address all the problems associated with first generation advanced conductor, they naturally lump TS as just one of the other carbon core conductor. The truth is different. And it is our job to make sure our customer base understand the fundamental difference of TS versus the prior generation product. Why we're safer, why we're more reliable, why we're easier to work with. This is fundamentally because of that aluminum encapsulation protection for the carbon core. And the second part, in terms of the slow adoption, is the fact that our customer base are regulated monopolies, and regulation plays a critical role. Yeah, regulation plays a critical role, and by definition, the utility commissioners make decisions on behalf of the ratepayers. They do not want the utility companies to take risk, because those risks are going to be shouldered by the ratepayers, right? Yeah. And that also drives the conservatism in our utility industry. And on top of that, utilities' intense focus on safety and reliability makes the culture ultra conservative. And then you have this prior generation product that hasn't done as well. So it's taking time, but there are enough progressive utilities in our industry that has recognized the value of TS, recognized the fundamental difference, and we have been blessed with their support, and this is what made the company successful. We are doing a major East Coast expansion to support our industry, and that's partly reflected by the industry demand for our solution.
Well, it is not easy to, let's say, incentivize a company that basically works in a monopoly. So it is very difficult to crack that market. But I also understand that, that industry, it is a heavily data-driven industry. Once you're able to show what are the actual results coming out from that, there is no way around that. Those are numbers, and they're undeniable. Talking about numbers, what I wanted to ask you, it is when I heard about TS Conductor, exactly from Bloomberg, they were talking about also in the context of green premium, for example, and they were saying that TS, it is much more expensive than a normal solution. But the way I think about this, and the overly abused green premium terminology, it is that you don't have just to look from a capex perspective. You have to look at this sort of investment throughout its entire life cycle. Likewise, you do from an environmental impact perspective. You also do it from a financial perspective. Can you please break it down for me?
Yeah. Let me put it this way. I'll give you the U.S. experience. When we build new transmission lines in the U.S., the cost of conductor is only a few percentage points. The cost associated with structures like the towers and the poles, it could be as much as 30% of the project cost. We do have I would say, green premium on conductor itself on a per foot basis. But when you consider the cost of the project, we actually deliver a green discount. And if we are adding line loss reduction, which gives you a green dividend every hour, every day, every month, every year, in terms of life cycle benefit, it's a no-brainer that TS offer the absolute best value. But let me go back to the green discount on the project cost, project CapEx cost. If you are doing new lines, for example, the TS technology with its stronger conductor and also low sag characteristics, now you can build these new lines, whether it's gen-tie lines or interconnection lines, with fewer and shorter structures. That creates enough CapEx savings, which more than offsets the modest premium associated with TS conductor itself, so that you actually have a net saving. And then you can also leverage, if you could, the line loss reduction by deploying TS technology, that green dividend. You basically have the potential to save the utility and the ratepayers money from day one when you deploy TS technology. And I should make a point, Francisco, that conductors are normally designed with 50 or 70 years lifespan. So what does it mean? Well, if we are continuing to lock in the century-old conductor technology, as we have been doing, we will be stuck with that technology for another 50 to 70 years. But if we make the right decision to switch to the next generation advanced conductors, you're able to benefit from that technology for the next 50 to 70 years. There is a fundamental difference when the utility make a choice on conductor. It matters. It matters to grid capacity and energy transition. It matters to the cost of electricity to the ratepayers as well. Because if they are able to leverage TS technology, whether it is reconductoring or building new lines, you could save on CapEx. And I do want to make a cautionary comment here that the utility business model in the past, it is a cost plus model. And what does it mean? Well, it means that the utility companies make money by building CapEx projects, and then the utility commissioners approve a rate in terms of the rate of return for that CapEx investment. So, the natural tendency will be, new lines and rebuild, which will cost more money. Reconductoring is only going to be a fraction of that cost. And so it may not be necessarily in the best interest from that particular financial model. And I would advocate something different that is also in the interest of everyone. For example, we have the potential to deliver green dividends enabled by technology like TS. That is in the form of reduced line loss. Why wouldn't we reward the utilities that is making the decision on conductor choice, allow them to keep at least a significant portion of that line loss reduction for them as a recognition, as a financial reward, and pass on the rest of the savings to the ratepayers? Now you make utility the winner, you make the ratepayers a winner, and you are also making our environment a winner as well. Policies like that makes a huge difference in our industry, and I would strongly urge anyone who is a policymaker, regulator, or who can influence the deliberation process of the regulations to really speak up and support these type of initiatives.
Okay, that is true. And it is, let's say, a very good approach to be able to redistribute. I want to take a little step back on what you said before, that if we are going to keep the same technology for 70 years, the same technology could stay for the following 70 years until we start to change, right? Dr. J, I don't think this is going to happen. We are living in a particular historical moment where we're witnessing so many technological advancements from every industry. You before gave a brief material science lesson about how cables were done from 1908 and then onwards. And now we're seeing what TS Conductor it is doing. I've seen what solar modules they were doing before, and right now you have that level of efficiency per square meter that makes sense. Repowering and revamping the power plants built 10, 15 years ago, because you have those authorization, building permits, and connection costs that you already have invested into, that right now are a higher component than the actual material that you have to use to produce electricity. So maybe in 5 years, it is the curve. It is getting steeper and steeper, right? In terms of new technological advancement. Maybe in 3 years, TS Conductor will come with a new advancement that would say, rather than have a 3x conductivity, it will be a 6x conductivity, and who knows? And then we start again. It would it will also make economically sense for utilities to adopt that technology again, because of what you propose for regulators and policymakers, right? To redistribute. That is fascinating, and it is happening in so many industries, starting even with artificial intelligence. God knows what they're going to bring to us on terms of research on material science. So fascinating times, really fascinating times. Are there, talking about technologies, are there any technologies that you think, together with TS Conductor, are going to be of help into, let's say, accelerating and removing the clog onto the grid?
Yeah, they are. I would say they are in parallel technologies like grid enhancing technology that allows you to do dynamic line rating. What it means is you're basically leveraging the existing infrastructure, squeeze out another 20 to 30% capacity to allow us to get by. But in terms of breakthrough performance, I don't see anything that is better than TS, because what we do combine in TS technology is the best mature science today has to offer in building a conductor. And you could also, which is something that we are actively working on, integrate smart smart fibers into the TS technology to make smart TS conductors. That will allow you to monitor line sagging and the line temperature real time, to allow the conductor itself to provide dynamic line rating real time at all times. Wow. It will also provide monitoring and impact from extreme weather events, whether it's wildfire, hurricane wind, or ice storms, for better resiliency.
That is very good.
I was intrigued by, Francisco, I was intrigued by your comments about conservatism, and also I share with your optimism of pace of change. But I have to be a realist here. I used to work in aerospace. I worked on aircraft platforms like 787, A350, as well as F-35, F-22s. I thought aerospace was conservative in terms of material adoption. Boy, how wrong I was when I joined the utility industry, tried to get new technology adopted. And I mean, what you have to keep in mind is our utility industry is conservative for a reason, because they are also expected to keep the lights on. So they have a very intense focus on safety and reliability, and they wanted to have something verified, proven true for 20 years by someone else, and then they will start to adapt. At least some of the utilities have that type of conservatism, which is understandable. And I do believe that we don't have that much time to address the issues in front of us. And we also needed to keep economic prosperity and viability going as well. This is why affordability is very important when we talk about grid modernization to support energy transition. The reason being, the ratepayers which is our mass population, they need to embrace what we do. And a technology like TS that delivers a green discount on project cost level, as well as a green dividend over the project life. It is important that we give full consideration of technologies like this. It not only solves the congestion problem, it also addresses the utility concern on safety, reliability, longevity, and workability. At the same time, it can deliver the economics that is expected.
Yeah, it is. It is incredibly misunderstood or not known the job that there is behind the stage that utilities does. It is an absolute staggering job. It's not that any person that is going to listen to this episode of Raw Green is not going to pick up the phone and call the local utility and say, "Hey, I'm going to consume this amount of energy right now. Can you please flick a switch because that's the amount of energy I'm going to require." You have energy immediately available 24/7, 365. And if you have those 5 minutes of power outages, it is the worst 5 minutes of your life. You think that doomsday is here, right? You start to blame any possible gods or religion around it. And the job that there is behind is huge.
I'll add one more comment that the grid is just the wires that are moving electrons. So we basically have to balance supply and demand real time at all times, right? And when you don't have the demand, you do not want to put the supplies on. That's going to overwhelm the system. And this is why that for the renewable generation, we need those power to be dispatchable power. This is why we need long-term storage solutions that is also affordable. And you could also look at it from the perspective that oftentimes in Europe, for example, we have negative electricity pricing middle of the night that the wind turbines are turning, but there's no load. Okay, the electron from wind turbines, they're going nowhere, right? And you don't want to stop the machines, so they're going to be spinning freely. But if we have the grid with abundant capacity, imagine the possibility that you are connecting the electrolyzers everywhere on the grid, and you can turn those things on middle of the night, that you are able to effectively leverage the electricity generation from the wind turbines to make hydrogen affordably. And those hydrogen can be used to blend with natural gas or used as its own fuel. And oxygen is useful for a lot of other things as well. But in let's say the next day, the grid is needing generation, you can reverse the hydrogen to water and create electricity and make the economics work as well. So the grid may be perceived as the impediment today in terms of energy transition, but it can be the enabler, and it should be the enabler for energy transition.
Love that. Yes, it's so true. That is so true. We used to think, or maybe it was until 10, 15 years ago, that it was unidirectional. You had that 2 or 3 sources of energy generation Now you have dozens of different sources of energy. You have the different forms of renewables, of solar with all the solar iterations. You have thermal with all the geothermal source of iterations, hydro, mini hydro, large, gravitational, and whatnot. And then starts with the battery with all the iterations. You have battery storage, you have thermal batteries, you have gravitational batteries. So it is amazing, the time that we're living right now. And it's true, it's a monumental challenge to be able to manage something like that. Thank God we live again in an historical moment where technology, it is at its peak, apparently. And we are able to also manage that. And I really like so much what you said, that it should be an enabler rather than the bottleneck of the energy transition. And again, what you also used at the beginning, no transition without transmission. So I think we have a lot of mottos into this episode already. We are able to extract for future shorts. Dr. J, thank you so much. This was a wonderful conversation, technical, and we find out several parts that can be further studied and that can be solved around the grid. Obviously, the value of TS Conductor, you mentioned it, but I also would like to mention it. I really like the technology for its simplicity and its effectiveness into bringing the transition, both from a, let's say, cleanliness and environmental impact perspective, but also from a financial perspective. Because again, when I saw that you were able to offer also generated savings, then that for me was the confirmation. Say, okay, yes, these guys, they have it. They 101% sure of their numbers. No bullshit there. Okay. Thank you. Thank you, Dr. J. I look forward to our next chat.
Thank you very much, Francisco. It's a pleasure.
Thank you, Dr. J. Bye. Thank you for listening to this episode of Raw Green. To get this far, you must have liked it. So don't forget to hit that like button and follow our podcast. It is a great way to support our community. At OBI, we're all about research, life cycle assessment, and green tech innovation. Stay connected with us through our social media pages or visit our website. Links are below in the description. See you next time. Ciiiao.